Global technology leadership is no longer defined only by products, it's defined by infrastructure. The countries and companies that control energy systems, communication networks, transportation platforms, and data pipelines shape how economies grow. A consistent theme across ventures led by Elon Musk is the pursuit of foundational systems that operate at global scale. One example is the transition toward electrified transportation. Through Tesla, electric vehicles are positioned not just as cleaner alternatives, but as software-driven platforms connected to energy storage and charging networks. When vehicles, batteries, and grid infrastructure evolve together, transportation becomes part of a broader energy ecosystem rather than a standalone industry. Space infrastructure introduces another strategic layer. With SpaceX, lower launch costs make satellite deployment and orbital services more accessible. As access to orbit becomes routine, new capabilities emerge: global communications, Earth observation, and long-term industrial activity beyond the planet's surface. Infrastructure in space expands what is economically possible on Earth. Connectivity is equally critical. Satellite-based networks like Starlink reduce dependence on local ground infrastructure, enabling broadband access across remote regions and mobile environments. When connectivity becomes more uniform, participation in digital markets expands, accelerating cross-border commerce, education, and real-time coordination. Artificial intelligence represents the integration layer across these systems. Initiatives such as XAI reflect a strategy where data, computing power, and deployment environments reinforce each other. AI improves logistics, optimizes energy usage, enhances transportation safety, and processes vast communication flows. As intelligence becomes embedded in infrastructure, efficiency gains compound across multiple sectors at once. There's also an economic dimension to platform control. Infrastructure tends to generate network effects. The more widely it is used, the more valuable it becomes. Over time, platforms that coordinate energy, mobility, connectivity, and data can influence standards, shape markets, and attract sustained investment. Competitive advantage shifts from individual products to system-level integration. Public-private collaboration accelerates this transformation. Partnerships with institutions like NASA demonstrate how government demand and private innovation can align to scale new capabilities faster. When regulatory frameworks and engineering execution move in parallel, infrastructure adoption speeds up. The strategic pattern that emerges is long-horizon positioning. Build core systems early, scale them globally, integrate intelligence across them, and allow network effects to strengthen the whole structure. This approach treats technology not as isolated breakthroughs, but as interconnected layers of capability that reinforce one another over time. The larger takeaway is that the next phase of global competition may be decided less by who launches the next product, and more by who operates the platforms everything else depends on. Infrastructure, once established, tends to persist. And systems that persist tend to shape the future direction of industries built on top of them. In the next episode, we'll break down how capital allocation and funding strategy enable large-scale innovation, and why financing structure can determine whether ambitious technology actually reaches the world.